Alright, in numbers 85, 86, 87, and 88, we're working with different types of chemical reactions. So in number 85, you're asked to write out a chemical equation for a synthesis reaction. In a synthesis reaction, what happens is that two or more reactants, we can call them elements A and B, combine to form a single product. So it's a compound made up of the two reactants here. In this case, our two reactants are boron and fluorine. One key thing to remember here is that fluorine is a diatomic molecule. Right, the list of diatomic molecules follows that whole Hunkelbrief thing I came up with. So hydrogen, oxygen, nitrogen, chlorine, bromine, and fluorine are all diatomic molecules. You're not given products here, so you need to figure out what the chemical formula of the product is going to be based on what the reactants are. You can do that by balancing the most likely charges of the boron ion and the fluorine ion. You can look at the periodic table to find out the most likely charges. So for instance, boron's most likely charge is 3+, fluorine's most likely charge is 1-. You need 3 of these fluorines to balance off that 3+ charge, so the formula for our product is going to be BF3. From here, it's a matter of balancing the equation. And you can do that by trying to start off by balancing the fluorines, and you do that by multiplying this by 3 and this second one by 2. And so that gives you a balanced chemical equation. This is a synthesis reaction. Number 86 deals with combustion reactions. In all these combustion reactions, one of the reactants is going to be oxygen. So here's oxygen there, and in the second one we have oxygen as a reactant as well. So in the first one, what we're trying to do is we're combusting boron. So we can treat this like we treated problem 85A, and the product will be some sort of combination of boron and oxygen. You can figure out the chemical formula again by balancing the charges, right? Most likely charge for boron, as we previously said, is 3+, and for oxygen is 2-. In order to balance the charges, you need 2 borons and 3 oxygens. So the product here is going to be B2O3. Once again, then it's a matter of balancing the equation. C3H6O, which is also known as acetone. Acetone is the stuff you smell in nail polish remover. Right, is a special type of compound. C3H6O is what's called a hydrocarbon. Hydrocarbons contain 3 elements: carbon, hydrogen, and oxygen. Nothing else, just those 3. And whenever you combust a hydrocarbon, whenever you react it with oxygen, you form the same 2 products every time: carbon dioxide and water. Depending on the temperature, it could be water vapor, so it would be gaseous, or it could be liquid water. But you get the same 2 products every time. Where it's going to differ is in the number of products you have. So different hydrocarbons will yield different amounts of carbon dioxide and water. So by looking at this chemical formula, you can tell that your products are going to be CO2 and H2O. All right, again, from there, it's just a matter of balancing out your equation. Problem number 87 deals with a decomposition reaction. In this case, we're given a chemical formula, magnesium bromide, and we need to figure out what it's going to break up into. So we start off by writing out the chemical formula for this, and again, we do that by balancing charges here because this is an ionic compound. It contains a metal, magnesium, bonded to a nonmetal, bromine. The most likely charge for magnesium is 2+, and the most likely charge for bromine is -, so you need 2 bromines to balance out that 1 magnesium. Okay, that means it's going to break up into these 2 things, magnesium and bromine. The key here is remembering that bromine is one of those special diatomic molecules. And it ends up that this equation is actually balanced without us having to add any coefficients, and that works out pretty nicely. Number 88 deals with a single replacement reactions. So in order to tell whether or not a single replacement reaction is going to occur, you need to look at the position of the 2 metals that are involved on something called an activity series. The element that's higher up on the activity series will replace the element that's lower on the activity series. In this first reaction here, right, we've got nickel and we've got magnesium. So you can look in your book at your activity series and you'll see that magnesium is higher up than nickel. Right, magnesium is already bound to something here, it's already attached to that chlorine, so it's got nothing to replace. As a result, this is going to have no reaction. Right, in the second one, the element that's on its own is calcium, and the element that's bound to something else is copper. It ends up that calcium is higher up on the activity series than copper. That means it can replace copper, sort of knock copper out of this compound. and lead us to form copper solid and calcium bromide. We can figure out these chemical formulas again by balancing the charges. So calcium's got a 2+ charge, which means you need 2 bromines, which have a minus charge. You have a minus charge to balance that out. You know the charge of copper because in the problem you're told it's copper 2 bromide. And whenever you see that Roman numeral 2 in the name of the chemical formula, that means that it's got a 2+ charge. So in this case, the first one, there's no reaction because magnesium is higher on the activity series than nickel. And then the second one, there is a reaction because vice versa, calcium is higher than copper.